Assalamualaikum and salam sejahtera to all my friends and also Dr. Muhammad Zalani. I am Zakia Maira binti Hassan, metric number S56671. Today I'm gonna present to you about the assignment given, which is I already choose basic induction motor concept for my topic assignment. What is induction motor? Induction motors are the most commonly used motors in many applications. These are also known as asynchronous motors because an induction motor always runs at a speed lower than synchronous speed, where the synchronous speed means the speed of the rotating magnetic field in the stator. Induction motors also works on the principle of electromagnetic induction. The next is the constructional feature. There are two main parts of the induction motor. First is the stator and the second is rotor. I will talk about the stator first. The stator of an induction motor consists of stator frame, core and winding. Stator frame is made up of cast iron and it holds the stator core. Stator core is made up of thin sheets of steel laminations. The stator core has slots for providing three-phase distributed AC windings in it, and also the stator winding consists of insulated copper wire. There are three-phase distributed winding connected in the either star or delta fashion. This is the figure for the constructional features of induction motor, and as you can see, there are already given the parts of the induction motors. Next is the rotor. Rotor is a hollow laminated core and having a slots. The rotor core is also mounted on the shaft. The rotor in the induction motor can be classified into two types, which is squirrel cage type and worm rotor type or slip ring type. What is squirrel cage type? Squirrel cage type consists of a laminated cylindrical core and having semi-closed circular slots at the outer periphery. In this, copper or aluminium bar conductors are placed in these slots and short circuit at each end by copper or aluminium rings. It is called short circuiting rings. The rotor winding is permanently short circuit and it is not possible to add any external resistance. The rotor slots are not parallel to the shaft but is skewed to reduce harming, provide smoother torque for different positions of rotor and also to reduce magnetic locking of stator and rotor. This is the figure for the squirrel cage rotor. And then the worm rotor. The worm rotor is also called slip ring rotor. In this, it is consists of a laminated core and having semi-closed slots at the outer periphery and carries a three-phase insulated winding. The rotor is wound for the same number of poles as that of stator. The three finished terminals are connected together, forming a star point, and the three star terminals are connected to three slip rings fixed on the shaft. However, slip rings allow for connection of external resistance in series with the rotor windings by using carbon brushes. This is the figure for one rotor of a large induction motor. And then the last part is the frequency. Induction motors have been called rotating transformers because they work by inducing voltage and currents in the rotor. Primary, which is the stator, induce a voltage in the secondary, the rotor, but the secondary frequency is not necessarily the same as the primary frequency. If the rotor is locked, it will have the same frequency as the stator. And if the rotor turns at synchronous speed, the frequency of the rotor will be equal to 0 and for any speed in between. That's all from me. Thank you.